and welcome to the video on the hydrogen bond, the intro hydrogen bond video. So the hydrogen bond, if you like, is a super strong intermolecular force, or a super strong dipole-dipole intermolecular force. And it is fairly strong as these forces go. It's about 1/20th the strength of a covalent bond. So it's nothing to sniff at, right? About 5% of the covalent bond strength. So it's sort of like saying it's a super strong baby, right? Babies tend to be fairly weak, but for a baby, right, this is pretty strong. But again, 20 hydrogen bonds would be about the strength of a single covalent bond. So it's pretty important if you're a biologist or a chemist, right? This is the kind of intermolecular force that your spidey senses should start tingling. And you always need two things. There's always two simple things that as soon as you see, you should start thinking about hydrogen bonds. And you need what we call a hydrogen bond donor. And in the same molecule or in a different molecule, you need a hydrogen bond acceptor. And so as soon as you see one and the other, you should start to think hydrogen bonds. So what is an example of a hydrogen bond donor? Well, what you need is a hydrogen that is attached to a super electronegative group. So oxygen, or nitrogen, or fluorine. And soon as you see that, right, you should start thinking that thing is going to pow, right? It's going to really have some severe interaction. And why is that? Because those three atoms are extremely electronegative. So they were going to pull electron density away from the hydrogen, and they're going to make that hydrogen super positive. And the other thing you need is the hydrogen bond acceptor group. And that is actually a lone pair on either an oxygen or a nitrogen or a fluorine. And the reason for that is that negative lone pair, right, is going to be super attracted to that positive hydrogen. In fact, we normally just say it's kind of a dipole-dipole interaction, but it's actually sort of a bond, a real covalent bond it makes between there. It's a special kind. It's quite a weak version, but there's something special going on. If you take an upper level chemistry class, you'll get to model this, and you'll see it's a little more exciting. But as soon as you see these two things, you should think, aha, hydrogen bond. All right, so let's try and recognize some molecules that can hydrogen bond. So the first thing, right, people always think is, gosh, if I got a hydrogen, right, I can make a hydrogen bond. So there's a molecule like methane, right? And you might say, well, they can hydrogen bond, right, through their hydrogens. But even though it's called a hydrogen bond, it is not just the presence of a hydrogen. So that actually fails the test because you don't have a donor, right? So you need a hydrogen bonded to either an oxygen or a nitrogen or a fluorine, right? And clearly a carbon is not an oxygen, nitrogen, or fluorine. And you don't have an acceptor, right? You don't have a lone pair bonded to either an oxygen, a nitrogen, or a fluorine, right? So you lack the three donors or the three acceptor possibilities. So that is not going to hydrogen bond. Okay, so you want to be on the lookout for molecules that have both of these. So for instance, if we take something like methanol, so methanol is CH3OH, and why have I drawn it down like that? Well, there's actually four repulsions around that oxygen, right? There's a lone pair, a bond, and a bond. Four repulsions give that tetrahedral shape, and if you've got just two bonds there, that's that bent shape, about 109.5 degrees. And so you should look at a molecule like that, and you should say, can it hydrogen bond? And the answer is yes, it can, because it's got the two things it needs, right? So it has got the donor, so the hydrogen attached to an oxygen, and it's also got the acceptor. It's got a lone pair attached to an oxygen. So the question is, okay, and you might pause the video after this, is where is the hydrogen bond in the structure? Pause it and point it out. Okay, unpause. And the answer is, it's not there. There is no hydrogen bond. The hydrogen bond is an intermolecular force. That means it's between a pair of molecules. So this is kind of like saying, well, what's the sound of one hand clapping, right? There's no sound at all. You can't point to an intermolecular force inside of a molecule. There are intramolecular, right, the covalent bonds, but there's no intermolecular force between there. So now you got to kind of ask yourself, well, where would the hydrogen bond form? And you got to do a little bit of sort of mental rotation here. So I can go ahead and I can take that methanol and I can take a second methanol and I can kind of draw it alongside. But I've drawn it in such a way that, say, the lone pair of the one oxygen, right, is next to the hydrogen of the other. So that would be an example of a hydrogen bond. So you might say, well, okay, well, why'd you do it like that? Why couldn't you just written them essentially one right next to the other? So I'm going to go ahead and just draw one next to the other. Apologies for my terrible drawings. And you might say, well, isn't that a hydrogen bond right there? And the answer is, well, it's half a hydrogen bond. And why do I say half a hydrogen bond? Well, you got the lone pair on the oxygen there, so that is the acceptor. You got the hydrogen on something that looks like the donor, but it's on a carbon. And remember, hydrogen on a carbon is not a donor. Hydrogen has to be on either a nitrogen, an oxygen, or a fluorine to be a donor. So this does not count. So you might say, can I be half right? Well, it's kind of like being half pregnant. You're either 100% or you're not at all. So you can't have half a hydrogen bond. So that is not a hydrogen bond. That is a hydrogen bond. Alrighty.